Hello and welcome back to a new video here on the Ludwig Fusel channel. Now this video again is totally out of the order of any other video because I am just trying to bring you something because I haven't done a video in quite a while. I'm working on a bigger video series. I have these active video series that are kind of like very slowly continuing currently. I'm doing a lot of this there on the channel currently because of multiple reasons. I hope that this can be stabilized, but however, well, here's another in the video. What I want to do is just that you have a bit of a content to write a small application, which in the end might be also big, that allows you to model 3D objects with Lua. Yes, you heard right. I hate these like applications like Blender. I can't be bothered using like Blender and stuff like this. I don't know. I personally, for me, the workflow that like Blender and these kind of applications are kind of like enforcing, well, I don't like it. I'm not an artist, I'm a programmer. So, well, let's write ourselves a new tool that makes these things a bit easier. Alright, so how do I want to call this one? Lua 3D? I don't know, Lua 3D is probably already taken that name. Or it has been already implemented somehow. Pure Lua 3D lib for nonce. Whatever, let's call this one Lua MDL 3D because I want to do 3D modeling with Lua. Boom, create a repository. I don't know. Now, what I want to do is I want to clone this. This is definitely the wrong folder. Let me clone this here. Git clone. There we go. Lua MDL 3D. Let's open this up with VS Code so that we can get started. Now, of course, we need some packages. I'm not sure which one to use. In general, we want to have Lua bindings, so we need Lua. There it is. This is Lua. We just need the basic one. I don't fancy in doing anything more special than like the basic Lua. And what I need is I need some way of parsing arguments. So let's put an arg parse and let's now integrate them. It's, I think, okay to use spdlog. I think we are on version 12 these days. Spdlog is never like a... Oops, this is some other stuff. spdlog is never something that we should not have. Okay, we are already at 13. Okay. So spdlog 13. Let's now, I don't know, maybe this repository still has some problems here and here. No, they should be fine. Okay, so let's take spdlog, which brings us fmt here as well. Let's add an arg parse for argument parsing and Lua as well. Since we need to export 3D objects, let's quickly see if there's a library for OBJ. Tiny OBJ loader. Yeah, no, I don't bother now taking a library for that. The OBJ file format is so simple, we can write a bit of code on our own to export it. Now this is now the Lua MDL 3D recipe. Okay, so the dependencies are fitting. Let's go now into the configuration. Let's call it Lua MDL 3D. Debug and release is my thing that I want to have. Let's maybe add the development configuration. I need to rework the template repository because I do think that there are now different style guidelines that you should apply when using Lua. Development. Okay, so debug, development, release. Because in the future I do wanna, spoiler alert, already have kind of like a 3D editor. Let's add the prefix in here. And let's make the architecture flat so that we can have multiple projects, because we're gonna have multiple ones. We're gonna have a Lua MDL 3D project, the Lua MDL 3D project, and we're gonna have Lua MDL 3D lib. So we're gonna have a library, we are gonna have a command line util, and we might gonna have a UI. Let's maybe name it dot lua mdl dot lib. Yeah, I don't know. Let's make it with underscores these days. And in theory, what I also want to have in the future is a lua mdl 3d.ui or underscore UI. Then this is gonna be moved here. Build.lua cpp console. That's fine. And the UI is gonna get something similar, but windowed in the end. Then let's adjust the configuration of the project. I do not want to call it like that. I want to call this one Lua MBL 3D UI. And this is quite similar on how I want to do it here. The only difference is going to be, now first let me copy the Lua file down here and to the library and add a dummy.cpp in here. Now in here, let's remove this and call this one Lua MDL 3D because it's the executable. Console is correct. And do it like this. Now in here, this is the lib. We do not need that. Lua MDL 3D lib. And this is now a static lib that is kind of like providing the features. All right, so what I now want to do is I want to link against these. So the UI requires these, of course. So let's add in some links and put in the library. All right, so let's take it from here and paste it in there so that we have it. I don't think that we're gonna use depends on no, we might use depends on the UI, might depend on the command line util. Probably the UI is gonna depend on the command line util because I don't want to write code like 15,000 times, or maybe. But I think it's kind of like a good idea to have it in here. But the command line util does not require that. This one does also not require it. But in here, I want to depends on the library, the executable itself. This doesn't link against it. This just assures that it's always been built. All right, so now we should have our basic project structure done. So let's do mox init to quickly initialize the project. Basically what the application shall do, it's basically gonna, or should basically be similar to how like Premake works with this kind of like REPL interface. So you can say like project CVP, but I want to have it for 3D models, of course. Now, as you can see, we now should have a bit of an adaptation in here. I do not want to commit this yet. And now we should have the Lua MDL 3D.sln. And if I open this up, we should have a correctly set it up project structure, which doesn't look too bad. But it's defaulted to the right one. And if I now go into my main.cpp, I should have just some spd log in here. The UI, it's probably not going to work, but if I press F5, this should compile and give us some hello world with spd log. Yeah, there we go. We get some hello world from spd log. So this is all done correctly. Let me for you zoom a bit in so that we can work with that. Maybe it's a bit, no, I think it's fine. Let's keep it like this. All right, so let's now start implementing a bit of the stuff. I haven't used Lua in quite a while. Let's just search for Lua. Lua.org was the address. Documentation. Okay. Application programming interface, text size. I do just want to have a quick example. Huh. Static int foo Lua get up. Yeah, but this is like a Lua called function because it's like modifying the Lua stack. Or do we use something like sol? Like a bit easier interface for Lua, because sol is basically, it should depend on Lua somehow. If we take a look at this, it should depend on Lua. With Lua, Lua, there you go. Lua 546, which I think what we had. Now, basically, I haven't worked with Sol, but I think it's a bit easier. Let's maybe try using Sol because it's a bit easier to integrate than normal Lua in C++. I haven't used it at all in my life. Multiple times taking a look at it, but never used it. Okay, so let's reinitialize. Let's see and hope that it works. It seems good. Let's now maybe just quickly try this example that they're giving. I do not want to have C assert because I don't like it. I want to have sol. And then I'm going to take this code and I'm going to paste it in here. So basically what we are doing is we are creating a Lua state, then we are setting x equals 0, then we are applying a function. The function is called beep. It's using a lambda to increment x, and then Lua shall call beep. And what I then want to basically do is I want to have a bit of an SPD log output. Log info x is now x, or let's just say x is, and then we're gonna move this somewhere up here, and then we have this Lua stuff, and this should now in theory call into Lua. X is 0, x is 1, so hey, we have successfully executed Lua code. That's how it is. Very simple. Lua is now working with C++. We can do it even better. Like, let's write a void log. Let's write a void log const char message. So I want to have a logging function that can log a message that says spd log info message, so that we can log something. And in theory, we should be able to also pass in the log function in here. I'm not sure how. Okay, so it's not as straightforward as this. We probably need to tell it how we are doing it. Is there's a read the docs page tutorial, quick and dirty. Sol 2, Lua state, Lua, aha. Right, so ChatGPT is very stupid trying to solve this issue because I have two types of code laying around. So let's remove all the X's and hope that ChatGPT will be happy to work with it. How was it with strings and Lua? I think this is PHP. Should be like this, right? So this is what I wanna do. And this is how I kind of like want to have access to it. It probably does include string, however, let's try it out. Okay, so let's feed this back to ChatGPT. Okay. So it should be properly wrapped. Is const actually working? Nope. What does this work in Lua? Like const, okay, yeah, sure, but no. This is of course, but why should I need to do it like this? Why does it work like this? Ah, what the hell? Why? Why is all 2? Why does it not work like this? Can I void pointer const as the string reference cast this? What? Like this? What the hell? What's wrong with Sol? Why am I not able to automatically deduce that this is a function? But does this work? This does actually work now. Lua file, do file. I think do file allows me to run a file. Let's open the file script.lua. Instead of doing it like this, and this should of course not work because there's no script.lua. And then it's probably returning a result, a certain result, but I don't care. Let's add a script.lua, and let's inside the script.lua say log. Hey, so I want to quickly log. Now let's log hello world quickly in here. Now this should say hello world, correct. So as you can see, this is now working as intended, and of course I can't open it like this. I can like this. Alright, so now we got this working. Now one thing with these open libraries, ChatGPT suggested it works like this as well, which would make these a bit more compact. So let's try it like this as well, and I think it should work without an issue. Alright, yeah, still saying hello world. This is a bit carnage why I need to cast the things around, because there should already be a function pointer. I don't know why I need to explicitly cast the types. But yeah. Right. So what I now need to do is I now need to generate some OBJ files. So let's try to mimic the OBJ file format. Yeah, this is ChatGPT. This is no, I think it should be this tab where I want to move the stuff in. I have prepared a bit of stuff here. Right. Okay, so basically how OBJs work, this is a German text, but it kind of like tells quite how it works. OBJs start with a comment, then there is a material link, then the name of the object is kind of like defined, and then you kind of like start defining vertices, vertice normals and stuff like that. It is also displayed here. So as you can see, it's a bit odd, I would say. Elements, freeform curve, display rendering attributes, G group name. It's a bit odd how they explain it here on that page. So yeah, I want to just quickly start with just having a way of emitting these materials. So let's go to lib, let's make a new folder. And let's call this one, how do we want to call this one? Let's call this one OBJ out. Or do we want to? I just want to call it OBJ because it's only going to support outputting OBJ formats. Now, inside here, I want to have a class called OBJ writer. Or let's call it OBJ file, because I do want to kind of like have something that stores everything that the file could have. So Lua MDL3D is the namespace, and then we're gonna have a class OBJ file, and this class now shall store all. Is it even good to have it as a class? Let's make it as a struct so it's publicly as accessible. Let's include string. And let's start with having an std string called the comment. So this is the comment of the file. Let's add some doxygen docs to this so that we know what's going on. So comment of the file. And by default, I want to have this comment to be Lua MDL 3D. OBJ modeler version 1.1.1, and then modeler is written different, and then I want to have a new line. What? Okay. So then I want to have a new line. In general, I do want to have some line conversions in the end, I think. But the next line is then going to contain some other code. Copyright. Like this. No, just a bit of information. And then the next thing that we're gonna have, according to the format, is we have the material lib. I want to skip this for now because we're gonna land in material support later. And we have the object name. Maybe since this is a struct, we can also do it like this. So then we have the object name, and by default it's called just object. This is the name of the object encapsulated in the file. I'm not sure, can we have multiple objects in one OBJ file? Now this is again German, but I kind of like trust this one more. Benennung des Objektes. I am kind of intrigued that maybe you can have multiple objects. Let's ask him, can an OBJ file hold multiple objects? If yes, give me an example. Okay. So you can have like the object cube, you can define the vertices for the cube. Come on, why are you doing a cube? Are you doing actually quad faces? Okay, interesting. The quad faces work as well. And that you can have an object pyramid. So what's the difference between objects and groups? Groups. Okay. So we have objects and then we have groups. Okay, so the kind of like order is that we have objects and then we have groups. So struct obj object, and we're gonna have a struct obj cube. This is how it should be arranged. Single entity. I don't know why they are. Yeah, it's kind of like probably because they are having like a REPL interface. Oh, not cube. Group. One object within the file, and then we have one group within an object, and the object is going to have a name, so object name, and then we have an std string group name, so that we have groups and objects. Labels the group, group. This is how you write it, group, like this. Okay, so labels the group, labels the object. And now instead of having objects in here, we're gonna have the group in here. So do we use a vector or a list? I don't know. Currently I've been going on and using lists a bit more than objects. A city list, because we don't need to really access the memory in a raw way. So obj objects. So now we basically have encapsulated objects within the group, within the file. And if we have objects, these objects are going to be having obj groups. And what do I want to do? If a group is maybe named without a label, it's just not printed at all. So yeah, we could do it. Groups within the object. I'm not sure how this with the material files and stuff work, but I think for now having just this structure is already quite fine, which kind of like mimics the way of defining like groups. But how are they doing it? Inside of an object you can define vertices, and then in groups you're defining the materials and faces. That's interesting. So vertices and normals are defined in here. Vertices, normals, and then probably also the texture coordinates. So in the file format we have like these vertices normal, VT and VP. What are they doing? Explain obj v vn vt vp. So v is vertex. That's quite similar. Oh, that's quite straightforward. Yeah, and vertex normal is also quite straight. VT is probably vertex texture coordinate. Yeah, don't yeah, okay, I told you explain, sorry. VT is vertex coordinates, texture coordinates. And what is VP? Parameter space. Yeah, this NURB stuff. So let's ditch the VPs for now. Let's do a V for vertex, a VN for vertex normal, and VT. So you can kind of like see UVW. Okay, so okay. So what I want to have is I want to have a struct called vector 2D. Let's call it vector 2F because it's float. I think they are using floats in OBJ. To OBJ files use float or double. Let's see. Yeah, but that's what's the common way. Yes, I know that this is text space. Okay, so let's do float because on the GPU we're gonna have floats always. So let's start this with an X and a Y. And then I want to have a vector. Let's maybe prefix them with obj vector 3f yz. Let's maybe also wrap it in a union and an anonymous struct to also have them like labeled uv like this. And let's make it x y z w, and let's make it, what the hell? Okay, UVW like this. Now it's okay. And then let's maybe have them as a 4F. We could also use some mask library. Is there some mask library available? So like GLM OpenGL mathematics, but highly optimized mathematics. DirectX math is probably not in here. DirectX headers, that's interesting. These are probably like these things that you don't really need. So I do at the end, this tool is not going to be cross-platform, so I can also include DirectX math. I can include DirectX math. So I want to quickly show me how to use DirectX math vectors for 2, 3, and 4 components. So let's ask our... No. Yeah, you don't need to tell me. XM vector, XM float 2, XM float 3, and XM float 4. Okay, so this is easy. I just wanted to know how these are called. So let's use them. Let's, instead of that, let's say, make it different. Let's completely delete them here. And instead of this, let's go, come on. Let's go in and say using equals this. Okay, so now this is 2 components and 4 components, and now we have an alias for them. And if I create myself an obj vector 2fv, it should be already having like x and y. Okay, w. Okay, it does not have the other components, but at least we have them in the DirectX format, which is kind of like what I want to do, because at the end we at some point also gonna have a way of displaying these, and DirectX is gonna be used. So yeah, it's better to already have them in this format. Okay, so an object now has kind of like groups, and I want to call them face groups. Groups of objects, faces. Or not faces, of object parts. And in here, we're now going to have a certain set of lists. And for these, I'm now going to actually use a vector, because I don't need a linked list for these. A vector is, I think, more beneficial. Let's use a vector of obj vector 3f for the vertices. Now, in general, how do the vertices work? Can they also be... Yeah, okay, x, y, z, w. Why would we use a w? Okay. Yeah, I don't think that it's going to be key. So we can just have a vector here of vertices. J vector 2f, and actually let's make this a vector 3f. This is now for the... they first wanna... Yeah, let's first do the normals and then use the texture coordinates. Normals. And then let's make a vector 3f for the text squirts. And then let's make a boolean text squirts 3. No. Text squirts 3d equals false by default, which will then be reinterpreted as like smaller scale coordinates. Alright, so like the vertices of the object. And then we have the normals, which is normals of the object. And then we have text squirts, texture coordinates of the object. Alright, like this. Of the object, okay. Now we basically have defined how an object works. Now we just need to define how the groups work, because the group is kind of like the collection of faces, or better to say indices. Now I'm gonna say it's gonna have a struct, which I'm gonna call obj face. This is now defining a single face of a object. Now, in general, what we're gonna have is, let's actually call this one obj face 3 because we are talking about triangles. And then I want to have a uin32t that is kind of like giving me the coordinates. CSTD int is used for this. And now I'm basically gonna, well, let's make them obj edge. Let's make an obj edge first, which is kind of like a single edge that binds coordinates to the normals and textures. And then basically what we're gonna have is uin32t, and I'm gonna call this one vertex index. And then we have normal index, and then we're gonna have text chord index. And now basically this edge is like binding to one point, and then I'm gonna have a struct obj face 3, which defines a triangle, and this face 3 has now an obj edges, and now we now have 3. It's actually not, it's actually an obj point. Edge, because like edge is more like faces, edges, and points. We're not really obj. How binding point. Point bind. Let's just call it point because it is actually a point. The point is defined by these, and then I can say face 3, which is basically defined by 3 points. So now we have the points, and now it's defined. All right. So this is how it is. And now what I basically want to do is I'm going to name this one defines a triangle from points. We do want to only talk about triangulated objects because this is what we are doing in real-time rendering. So let's create a file, a source file, and let's now write a bit of magic. What I want to have is an O stream as an include, and what I want to be able to is I want to support streaming them to O streams. O stream operator. I haven't used them in quite a while. Please give me an example. What? Exafloat 3. Okay, because vector is then loading there. Okay, please give me an example of the C++ stream operator into a O stream. So I just want to quickly see how O stream works because I'm a noob and I don't know this out of my mind. But it's probably like just O stream reference operator shift O stream and then the object, something similar to that. Come on, don't really write myself a whole don't give the person so much details. It's exactly as I intended. So std O stream reference operator shift, and we have an std O stream in. So this is the stream called out, and then I need to support my my stuff. So obj point is the first thing that we want to stream out. It's a const obj point pt. It's in Lua 3D. It's the point that we want to stream out. Obj face 3. Phase 3 is what we want to be able to stream out. Then we have the group, which I'm going to call group, that I want to be streaming out. Object, this is then going to call it object that we want to stream out. And then we're going to have an obj. Yeah, the vectors in general should be a thing that we should be concerned. Or are we concerned of them? Yeah, we are concerned of them. But let's make them as a file first, and let's now start with the vector 2f, v2f, and the same for 3 and 4. I think we are not using 3 and 4 yet, but let's put them all in here. We don't care about descriptions because it's just a stream output operator, and we can implement this one. Right. So, oops, I don't want to print. Oops, no. Create implementation. Create implementation. All right, so how do outputs of the vectors work? Well, if we are taking a look on the, it's the wrong tab that I've opened on, no, this one. Basically, they are just spelled out here with a certain position of 1, 2, 3, 1, 2, 3, 6 is always 6. Yeah, we should be able to kind of like adjust the position at some point, but I'm gonna say position is 4. I don't know, is 4 correct? Yeah, let's I think it's 5 because it's, let's ask ChatGPT. Again, wrong tab. How to set our stream precision to output for OBJ files with 4 digits after with 5 digits. Okay. Let's see. SCD fixed. Okay. I am just now hoping that you are knowing what you do, ChatGPT, but I think you should. So SCD fixed is known, but we are missing IO manip here. IO manip to manipulate stuff like this, which should make this one work as well. And then we can stream out v3f x, v3f y, and v3f z. So now we have it implemented like this. We just need to return out. And this is basically what we want to do everywhere. In this case, x, yeah, of course it's now called 2y, x, y, and this one is not existing. So it's like this. And for the vector 4, it's quite similar. We just need to have another set of these. ZW, okay. So now we should have a bit of this set it up. So let's continue on with the more appropriate stuff. Now, if we are defining a point, we are kind of like following that sequence here, this 2//1, which basically gives us the, if we're having a phase, we have 2, 1, 3, 1, which is kind of like Eckpunkte and Textur coordinates, Eckpunkte and normale, so edge, texture, normal. So it's edge, texture, normal, so it's out, then it's PT vertex, edge, slash, texture, slash, normal. This is the way this is formatted. And then let's take a look at the phase 3. So if I now want to define a phase, you can see that we are defining it with the dash, with the F symbol and then the 3 points. So what I want to do is I want to define an F for the phase. And I want to have a space. Then I define the phase 3 points 0. And then this goes on and on and on. And we have like the phase 1 and the phase 2. Okay, so now we have exported a single line of a phase. Now we are getting into the group. So the first thing that I want to check if group name empty. So if the group is not empty, Then I want to output the group's name, and I think the group name was like G, and the name, group name, and then we're going to do an end line like this. So that's kind of like the group name. And this should comply with what we had here. G. This is the group name. If we don't have one, it doesn't go. And now I need to iterate all over all of my contents. And if I have seen this correctly, we've not implemented this one. Yeah, the group does not have the faces in here. So std vector of faces. Faces, so faces in a group. And basically what I want to do is for const auto reference face in group faces, I want to say out face, and I want to do a new line. So this is basically how I output my groups. And now let's take a look at the object. First of all, if object name empty, not empty, stdc out, we're gonna object name. We're gonna output the name. No, not stdc out. We're gonna go in here to the out that we already have. Right, so now how do we now define the objects? This is going to be a bit more involving, so let's take a look at this. This is the comment, this is from the file, then we are here at the object, we are outputting the name, we are starting with the vertices, with the textures and the normals. Vertex, textures, normals. So for auto or const auto reference vertex in the object vertices, I am going to say output the vertex. And I think the vertex is already something that we can print. Now we can print a new line. However, I think for vertex we still need to have the prefix, because this one is not inserted in here. So we are iterating, outputting the vertex prefix. Then we have the texture, so we have the text coordinates. Text coord, so the coordinate, we are outputting it like this. However, this is now not taking into account if it is a 3D texture. So if object text coord 3D, so if we are on a 3-dimensional coordinate, it's simple. It's as simple as we have it here. So we can output it straight away. If we are not 3-dimensional, I need to have a obj vector 2f, which is a Lua. So we have a vector 2f, so v2f, and the v2f is being constructed by the text coord x and the text coord y. So we now basically extract these, and then we are doing the same story, but now we are getting the data from somewhere else. So now we need to have the normals, normal in object normal, and now we need to spill out the normals, so vn for the normal, and then we just spill out the normal. It's very simple. And then we have the faces, so for const auto reference face in object, so we have no. We have normals, if the object name is normal vertices groups. So we are taking a look at the groups. So we have the groups, and then we are kind of like outputting the groups. So groups, group, and this is already doing its new line on its own because it's kind of like iterating down the line. And now we just need to have an output operator for the file itself. So the file itself starts with the comment. Gruppenname, use material. We are kind of like not using materials and stuff like that. So that looks good. But as you can see, we are starting with the comment and then with the object. So we actually need to work a bit with string streams, which I think we can't because they're not included. strings as a stream in here, because we now need to basically pass the comment line by line. So we are adding the file comment in here at some point for auto const auto object in file objects. We are going to go to out, and we are outputting the object. But for the comment, it's a bit more involved. So string line, so while std get line from my SS to my line. I think it works like that. So while we are getting lines, I'm going to add a hashtag, and I'm going to add a line, and I'm going to add an std end line. So this is how I want to extract the comment lines to write the comments. And this should now more or less allow us to write OBJ files from structured data. I think the include passes are probably not set up correctly, but they should be somehow usable. So Lua, okay, they are actually usable. OBJ file. Let's now take this OBJ file and tell ChatGPT to generate myself a cube. Right. Please use this header as an information. So then we have the content of the header. Objects, that looks fine. Please generate me some C++ code that fills the given, it's a thing called OBJ file. OBJ file struct with data defining a cube. Each side shall have its own group. So let's see if ChatGPT is capable of doing that. Let's see. It would be really nice if this works. This looks quite nice already. This looks very promising what ChatGPT is doing. This is giving me so much more like non-time waste. Oof. Really? Okay. I have no idea if this will ever compile, but it does really seem currently what it's doing quite legit. Yes, you shall continue generating, please. Okay, nice. Okay, you don't need to explain what your code does. I understand what your code does. I'm just lazy. Let's copy and paste this into our project and see if this ChatGPT experiment goes well. Yeah, let's keep the Lua stuff in for now. Let's paste this in here. This will not work because Lua namespace stuff, but this is not too big of a deal. We can add the namespaces in there. This already looks quite promising. I don't see any issues, like compile time issues yet. So let's try it and see if we are getting a proper file. So let's obj file, and let's make a breakpoint here, and I just quickly want to see if it compiles, if it does something, if it throws me an error. But as it seems like it does kind of look well. So I have one object in here. It is called cube. We have some vertices, 8 vertices, 1, 2, 3, 4, 5, 6, 7, 8. We have 6 normals for each size. This is okay. We have 4 texture coordinates. That is okay. We have 6 group for the faces. And each group is containing like 2 objects, which is fine because we have 2 triangles. And we have some indices in here that don't look too bad. So that's already enough for me to kind of like see that it might be plausible to do. So now let's open a file and just write this out. Fstream, let's quickly see if this works as I intended it to do. So std so offstream fout /my or cube.obj std ios out, so just like this. So f out, and I am just gonna spill it out like this. I don't really care about anything else. Let's see. If we are here, let's continue on. The file should be closed, and in VS Code we should see a cube.obj. The name of the cube is not correct. Everything else does seem good, but there's just cube in here. This is probably because I forgot to, when I outputted the name, to output the O prefix. But this is fixed fast. And now we should have an OBJ file. So what happens if I open this? No, it's going to open this with anything but not what I wanted to do. Open with 3D. How is that application called? Paint 3D object viewer. Come on. 3D object view 3D. Oh, come on. Okay. Blender. I think Blender should be able to open it, right? Oof, Blender 4.0? Yeah. Whatever. It's not too big. Yeah, we can just casually install Blender within a YouTube video. Shouldn't be too big of a deal. I don't think that I have it. No, I don't have it on this Windows install yet. Sad. Would be fine with an old version, of course. Idle time. Yeah, let's open it. Preparing to install. So next, I accept. Next, Blender. Yeah, install it wherever you want. I'm currently really populating my C drive now. I do kind of like have a drive for my applications, but well, why should I use it when I can just install everything on C? Now, come on. Blender is a big application, but please don't take too long. Okay. So, Blender. Hey! I've installed you. Blender. There it is. Okay. Language, English. Continue. Go in. Delete. That's how you work with Blender. And then just casually drop it in and hope that it works. No? Oh, come on. Open. Can I open something that's not a Blender file? Let's try it. If I can open a OBJ file directly. I can't. Can I import it? Import wavefront OBJ, cube.obj, and yeah, it somehow worked and it somehow did not work. You can see that we have points here that seem to be correctly arranged, but we do not see to get like faces. We have these vertex groups. They are kind of like group, but they are not a face. That's interesting. I don't know how to work with Blender actually, which is a bit bad, but Somehow our groups are in here, but they are not. 3D, please. Thanks. Why do we faces are not joined? Okay, so what is the problem? Is this a material problem? Do we need to have a material? So, okay. So let's do the feedback loop back to ChatGPT and ask ChatGPT what's wrong with my wave, with my OBJ file. So let's copy and paste this in here. What's wrong with my OBJ file? Blender shows the vertices, but not the connected faces. Okay. So let's ask ChatGPT. It's really a handy tool for things like this. You did incorrect indexing in your face F definition, especially the texture context VT starts with 0. Oha. It's one based indexing? Ha, interesting. How do I implement this? If we have one based indexing, I think, yes, I know how to index it, because we have an operator that's putting out these indices. So what we are going to do is we're just going to add +1, which can screw up the stream as far as I'm concerned, but it does not really seem to screw up the stream. But I did just want to quickly add some brackets around that to just add 1. But I think it's fine. So this should also already be finished. So let's delete this one again and let's try to import it again. Let's import it. And yeah, it's at least better. But something does not seem right. This face is good, this face is good, but the other ones are not. We have a bit of a few defunct triangles. So we have... Okay. Interesting. Ah, come on. I hate the shortkeys in like applications like Blender. Some faces seem to be good and some seem to be completely messed up. Okay. How can I find out which is which? Can I go and edit these? Which mode am I currently? Object mode. Let's go into edit mode. Yeah, edit mode is a bit more what I was intending about. So you can see, is this a vertex? Is it the origin? How can I do this? Like 1, 2, 1. 1 is, I think, vertex select mode, right? Yeah. So this is just the origin, I think, because I cannot deselect it. Edit, deselect, I don't know. But I cannot click it and I cannot unselect it. So this is kind of like the wrong one. I think I'm also missing vertices, right? Like, let's see. Do the vertices seem to be correct? Like, I have a vertex at minus, minus, minus. Actually, I should have a combination out of all vertices. Like everything plus and everything also a minus. So I have it. Let's maybe let's quickly open up Notepad. And let's write this down. So we have minus, minus, minus. We have plus, minus, minus. We have plus, plus, minus. I have minus, plus, minus. Minus, minus, plus. Plus, minus, plus. Plus, minus, plus. Plus, plus, plus. Minus, plus, plus. Okay, so let's validate these. Actually, it should have the equal number of plus and minus at every digit. Is that correct? Or does it not? Is like that. So, but what I can see is I can see that I have all extremes. So I have minus. Let's try to order these. Let's try to order these into binary counting. So let's see it like this, and then this one would go in here, so we would count, and then like 1, then we count up to this one, these two, then we count to this, then we binary count to that, and then as you can see, like let's mark these as existent. Let's mark a exclamation mark as non-existent, because now it would be, but we already have this. No. What am I thinking? Minus, what happened if I count again? Minus, plus, plus. We have minus, plus, plus. I'm an idiot. Minus, if we count up, yeah, it moves to that. Minus, plus, plus. And then if we count again. So the vertices seem to be fine. I think the vertices are the correct ones that we need. Just the way how it's built to a cube. However, what I find quite intriguing is that I'm missing a vertex here. I'm missing one that's in here. So what was the issue? What is the index only for texture coordinates? Is the one base index for which kind of index do I use what kind of counting? I look for position, normal, and text codes. Let's see. Let's see. Maybe it's not all. Hopefully you can format this position. Vertex starts at 1. Yeah, I don't need 100,000 explanations. All start at 1. One, two, three, four, five, six. 1, 2. I now got this file and it's still not displayed as a cube in Blender. Come on, I don't really... Vertex... Yeah, that's not a problem. Did the ChatGPT code already taken into account in here? They are adding a +1 everywhere. Which is not how things should go. But if it was already using like the +1 notation, why was it a problem? So import a OBJ. Okay, so now that I've corrected these, it seems good. Yeah, now we get a cube. Hi, haha, finally we got one. Texture coordinates don't work. This is because ChatGPT has not generated a correct code for displaying the texture coordinates, but we could fix that just by simply having make face. Yeah. vertex 1, 2, 3. They are using the same normal index. And they are using texture coordinates. How would this work? So I would start at the correct one. I don't know. I think I'm just gonna keep them as 0 now. Okay, but as you can see, it does work. Which one do I like? I've read this one. I know. Okay, so now we at least have a cube inside of Blender, and I think for today's video, I'm still trying. Was it? Why am I not able to use Blender? Is it so hard to just rotate around? What combination of keys do I need to press to rotate around? No, probably not a Windows key. What was that? That's an interesting selection tool. I don't know. I am always a bit lost when working with Blender. But as you can see, I think that it is kind of fine. We have generated ourselves a 3D object. That's a good starting point. Okay, so thank you for watching. See you in the next video. Make sure to like and subscribe. And have a nice day. Bye.